to lay it down on a center line. Okay, it is going to look like now. In here I have and a quarter National Fine Threads in this section. This end is knurled, and as far as some of the dimensions go, if you were going to look at it over here, you would see the hole, the threads, the next OD, or the outer diameter of the whole part, and that counterbore on the bottom end. Okay? From here to here, .25 inches. Precision isn't required on this part. There's no special requirements, so the closest you can get to 2 1/4, if you're plus or minus, I don't know, 2 or 3 thou or 5 thou, let's say, plus or minus, and you're supposed to write this. When you're writing down values, okay, and they're in decimal form, if you're putting down standard or imperial system, you don't mark the 0 before, and you don't mark down your inches, right? It's understood on the plan, if you're looking on the plan, right? But here, in a fraction, you would put down your inches symbol, right? Okay, and from here to here, the bore I might get it wrong. 3/8 is 375, I think, but it's 3/8, okay, and from here to here, this is 1.5, okay, from here to here, and overall, the overall length is 1 3/4, okay, and this countersink bore is 3/4 of an inch. And the width of this knurl is 0.25, which is 1/4. Okay, so overall length 1 3/4. Knurl is 1/4 inch wide. The bore, the countersink bore here in this section is 3/4 of an inch, and the total OD of the knurl is 2 1/4, and the width of the cone is 1 1/2. And so if you got all that down. Now, as far as these dimensions go, I want a quarter radius, and I want a 10-degree taper on here. So if I start cutting my taper from this end, as soon as I get close to my quarter radius, then I can just radius out. But I have no idea right here what that dimension is without calculating it with geometry, right? Or a trig, I should say trigonometry. Okay. So let's get started. I'm going to start off by cutting some rough stock, half an inch longer than that. So I'm going to go 2 3/4. Rough blank. Okay. That's a 2. Okay, that's going to be my rough blank. So let's get started. I want to hit the center of the part because the knurl is already to its proper diameter on this thing, so I have no room or give, right? If you want a quick reference, your chuck, there are lines in here, and I think they're spaced 3/4 of an inch apart. Yep. So that's 3/4, 150, 225, right? So if you bring it up to the line, you have a quick reference, which is kind of nice. Some chucks are smooth faced, so you don't have that capability. So, in reality, I'm going to bottom out this piece and flip it over later, right? So, I think I'm going to take it down a bit to, instead of 75, go half an inch. I'm not even close. And I'll loosen this off. Put it here. Tighten the highs and loosen the lows, right? That's if your indicator's on your side. It's reversed if you go on the opposite side. So instead of tighten the highs, it's loosen the highs and tighten the lows. Still warm. Burn my hand. There's bottom. Bottom down onto the face of the chuck. Now I can start indicating that. Bring over my dial indicator and put my spindle in neutral and just bring that up to 0. So that's zeroed right now. And if I bring it over, now I'm going to face off the part, and I'm using an insert, and an insert's got to be either carbide, ceramic, or ceramite, or could be borium nitride, borium nitride, something. That's for if you're machining in canal or something, like really tough material, and you need toughness, heat, and all that. You always want to choke up on your cutter, but you can go cutting, since I'm going to treat it as a high speed steel bit. So you go like this would be 4 times 100 divided by the diameter. So 400 divided by 2 1/4 is 200 RPM, should be good. It's probably capable of more because the insert okay, I faced off the part, and what I'm left with now, like I broke a little chamfer on the exterior so I wouldn't cut myself. I faced it off. Now I'm going to drill in and actually go and put in that, what's the dimension now? 1 3/8, and it's 3/4 deep. Okay, so I want to make a hole 1 3/8 OD, and I want it to be 3/4 of an inch deep. Okay, but I left myself some material for chucking, so I gotta include that in my measurements, right? So instead of going 3/4 deep, I gotta go an 1.25 deep, and it's gonna be 1 3/8. That's how I'm gonna do it. Now I don't have a 1 inch and 3/8 drill bit. This lathe couldn't handle it, so I'm going to have to bore out to the final dimension. And like I said, it can be plus or minus a 5 thou or 10 thou. It's not a critical dimension. So now, this information is incorrect. So, I made a little chart. I found this information in the machinery handbook. Okay, I've got carbide cutting tools, and they're going to be used for boring this cold rolled steel. The distributor I bought it from couldn't tell me much about it. I think they're more of a fabrication than machine shop. Okay, so I'm guessing it's 1030, 1015, maybe 1015 or 1010 cold roll steel. And this chart for cutting speeds and feeds for carbide, since the diameter of this is 1 inch, where I'm going to start my boring operation, is 1 inch, and I'm going to go at 20 thou. If I can go 20 thou, I'm going to use anywhere between 550 and 700 surface cutting speed, which is in feet per minute. Okay, well, I want that in revs. So to get this in revs, spindle speed RPM, what you set your machine to, you take your cutting speed. Let's say I'm going to go with 550, times it by 12, and divide it by pi times the diameter. And this will give me the RPM I should be running this, so I don't burn out my cutter. And the feeds, depth of cut is 20 to 90 thou. Okay, so it gives you a wide range, wider than the first one. Okay, and feed per revolution, which is either the lead you want on your machine, would be 5 to 15. Now, I'm not sure this machine, I cannot adjust these. They are pre-adjusted already. I got a fine and a coarse cut, which I have no idea what they are. I think it's around, I think my fine might be around 3 to 4 thousandths per rev. I'm not sure. And yes, that is something I should find out, but that's why I'm sticking with the lower value and see how it's going to work out. Okay? So we're going to set up the tool and get ready for that boring operation. Bore, okay, seems to work better if you feed it harder, right? Light cuts tend to want to chatter. 40 thou and up seem to be leaving a half decent finish. I might be able to get it better, but my machine seems to bog down at 40 a little bit, so 40 it is. Now, this part right now is, I've plunged or bored this hole out of it. I am at this dimension, 1.3755 plus or minus 5/10, because my indicator does not do more or better than half a tenth. Repeatability, okay, and that hole is at 1.62 1.612 thousandths deep, okay. So I've left myself some space here so I can clamp it. And once the part is done, I can actually part it at 1.175. Okay? So I've left myself some space here so I can clamp it in the chuck. And I won't destroy my knurling pattern on it. And I can machine the rest of it and make the threading it. Okay? Because eventually the part with the thread and then the and then the knurl. The knurl goes there. Okay, so right now I'm going to actually put my knurl in there, so that'll be done, and I can flip it over, chuck it, and finish the rest of the work on that part. Now, the book I'm using right now to do this has an arbor in it. And I don't know if the arbor wasn't made to actually a screw in there to hold it in between so I can knurl it between centers. Because the arbor has the same tread pattern as in here. So I could have screwed it in here and then just centered it and then made my knurl and finished the rest of my work. I think that's what the arbor was for. But the way I did it, I'm going to chuck it and finish the work. This is, I've got two type of knurlers. And the only one, I've got this type. I wish I had the scissor type, but I don't. And I have this type. Okay. I've never tried this one before, and when I started counting the teeth on these cutters and the diameter they're at, they don't match the machinist's handbook. So I don't know what kind of pattern I would get with this. But this one is made by Gross, G-R-O-Z, and it's got three patterns. It's got fine, medium, and coarse. I'm going to try making these coarse, I believe. Okay, so you just mount it in like that, and it centers itself on the work by itself. Okay, so that's what I'm going to do now. Alright, so when knurling, this is the speed you should be knurling at, or making your knurls. This is what the machinery handbook recommends. Now, whether or not your machine can do it depends on rigidity and all sorts of factors like the horsepower of the machine and everything else. But in theory, knurling, your knurl RPMs are a quarter of your machining speeds. Okay? And so far with this piece, my givens are the OD is 2 1/4, or that's what I want for a finished knurl. Okay? And oh, I skipped this spot. I'm going to have to machine the OD of this part again for the proper size so this works. Okay? So I got 2 1/4 OD, cold roll steel. My cutting speeds for cold roll steel, if it's a 1010, something like that, 1020, or it's 100 feet per minute. Well, I have to convert this to RPM, right? Because that just says I can take a cutter and scratch 100 feet in 1 minute, and the cutter won't go bad on me. And that's for high-speed steel. But to find the RPM, you take your cutting speed, times it by 12, and divide it by pi d. So I get 170 RPM, and then I got to divide it by 4 because I want a quarter of it, which is 42 RPM. So my knurls should be done at 42 RPM. And I'm going to have to go with what's on the machine. And my lowest speed is actually 75, which is a lot more than I'd like, but I can't go any slower. Okay, so this is some of the theory behind it. It's from the Machinery Handbook 29 at page 994. I don't know if I'm in the shot or not. And my givens with this piece is my knurls have a helical angle of 30 degrees. The stock in the chuck is 2 1/4. The knurl diametrical pitch that I'm using is 64. And you can get different sizes, right? There's 4 of them, the most common, but my coarse one is 64, and the OD of the knurler is 5/8. And this formula here, well, my part, this is still the part, right? 1/4 of an inch here, and the rest goes this way, thread and a taper on it. The thing is with this piece, I've already bored it out. This piece, if I stick it out, I don't know, 1/2 inch, and clamp it down. In my 4-jaw chuck, what's happening is they start to bell mouth. This part, instead of the jaw staying parallel with the surface, they start to bell mouth, because the spacing from here to here is so small that if I apply pressure to it, it starts to flex out. My lathe works for small things. It lacks rigidity. There we go. So I decided I would machine the rest of this between centers, but to do that I need a mandrel. So I've actually started making one. The threads on the mandrel are going to match the threads that go inside the part, and this is going to be the surface where this mates to that part. Okay. The only thing that's critical of this part is that it fits in the taper, in the borehole, and that the threads match the threads that go in this part. Once it's threaded on, as I lathe on it, I start taking cuts, it's just going to tight down on the mandrel. All I got to do is free it up to finish the part. I started doing this, right? It's sort of to protect any centers I make in my part. Like, let's say I dropped it on the floor. Well, I wouldn't mushroom my center. I'd just ding the outside lip of that face. I wouldn't go damage the inside of the part, right? I'll never damage this surface or the trueness of that hole to make sure it's centered. Now I ran into another snag. My lathe dog, to finish machining this between centers, is a 1-inch lathe dog. It won't clamp down on this properly. So I'm going to make one.